welcome everybody. I'm here with Jim Chappell from Aveva. Thanks for joining.
Thank you very much.
Now, I'll start with the role a little bit. Is the global head of industrial AI. Maybe expand a little bit of some of the trends that you're seeing in industrial AI, particularly in the context of manufacturing, energy, and infrastructure, which is what our audience focuses on.
Yeah, that's definitely a big area and an evolving area, and it really goes across engineering, operations, maintenance, and data itself. And what we're seeing is a couple of decades ago, AI started moving into the industrial space. Predictive analytics, predictive maintenance types of programs started in heavy industry, and then that started evolving into other industries, CPG, food and bev, chemicals, and so forth, and is continuing to evolve. It's become much more mature in things like heavy industries, power, oil, and gas, and continues to permeate other industries. Predictive analytics is getting more sophisticated, and then you just see that same trend, that same evolution. Mm-hmm. One of the trends we see in AI in the industrial space is that we're no longer just infusing, but we're integrating AI. And what do I mean by that? Well, you have machine learning in predictive analytics, predictive maintenance, but now they're starting to put in deep learning for future forecasting. Like, what's the remaining useful life of an asset? Can you make it to the next planned outage, maintenance outage, or what are my operations going to be like in a month? And then you're also putting in other types of analytics, like simulation integrated in. And so by doing this, you get more sophisticated, and more as things evolve. So that's the trend that we're seeing over the last couple of decades in industrial AI.
And I've seen a little bit of a demo last night, thank you for that, and some of the concerns with the data as to the ownership of data, particularly in the learning model, right? So there may be some data that in some industries that it's readily available, and whoever supports that, they want to make sure that it's readily available for everybody, for the good of everybody, but there may be some to protect it. Are there industries you see that, okay, they want that data to be shared, and not as concerned with, oh, it's my data, I don't want, if I'm an oil and gas or a CPG, I don't want the competitor to learn about it.
Yeah, absolutely. And even in some of the areas like power generation where you might think they're very secluded, they want to share subsets of their data with their suppliers and other things like that, and partners and so forth. So yeah, absolutely, we're seeing that. And that's where the cloud comes in. That's where the data comes in. And then once you have it in the cloud, you can apply analytics, AI to it for even more added value, and then share the results of that in a very secure manner, like you said, with other parties and related entities.
Got it. So over the last couple of days, heard various executives, including Rob McGreevy, the CPO of the organization, and talked about the trust and the data quality. Can you address that? How does Aveva address that data quality? And we won't get into security because that's also a never-ending story.
Right. Yeah, so data quality is very, very key. As you know, data is the lifeblood of AI, and garbage in, garbage out. If your data is not good, you're not going to have high quality AI models, regardless of whether it's generative AI with large language models or whether it's predictive analytics or anything in between. And what we do is we use AI to help cleanse the data going in. And so it could be something as simple as flatline detection, if you have a dead sensor, IIoT type sensor time series data, or we actually look for outliers, multivariate outlier analysis, so that if you have outliers there, it can automatically cleanse the data. And beyond that, we allow for advanced visualization, so it's super easy for subject matter experts to see, hey, all right, you did the basic cleansing, but I know there was a problem last June, and I don't want to train my model on that data, so you can easily visualize it and just literally circle it. Very easy methods of manually cleansing it as well if you have some kind of expert knowledge on a process or an asset as well.
Got it. Thanks for those insights. Now, there are folks in the audience, right? So there are some large companies there, and the perception about the AI that it's great for large companies. Maybe can you touch on what's in it for small companies, and what do you see some of the products on a roadmap that may be addressing those small to mid-sized companies, right? And if I looked at, I just had a conversation in Midwest with a couple of organizations that moved on this becoming a lighthouse. And when I asked the question, why did you come a lighthouse? Well, it's fear of missing out. So how does small to mid-sized company get into that area?
Yeah, the cool thing about AI is people are using it and they don't even know they're using it. You know, with Google, with so many tools out there. And it's proliferating into software that's relatively inexpensive. You know, Salesforce and Microsoft Office 365 and all of these tools are using various types of AI. So it's much, much easier for smaller companies to get into it because it's in commercial products that are relatively inexpensive. You no longer need to hire a bunch of data scientists and build your own sophisticated applications like you did back in the 90s when they were building expert systems and other things like that. The other thing is, as technology evolves, it becomes more accessible. So take ChatGPT for good or bad, but the large language model that was trained is the big differentiator. Generative AI, of course, has been around since the 1960s. The big difference lately is the development of large language models. The hardware has become more sophisticated, the access to the data. And this gives smaller companies and individuals access to this. And you ask about what applications or specific.
What are some of the specific use cases perhaps for them that, hey, I see this going, you may not be there today, but it's coming fast.
Yeah,
so.
I think one good one is low code, no code. And you know, low code, no code can help develop AI. AI can help improve low code, no code. We see it not a one way, but a cycle, a circular, you know, self-fulfilling situation. And low code, no code allows just, you know, it used to be that you had to develop models and train, and it was fairly complicated, and you need to understand a lot about data scientists. No longer the case. Drag and drop, point and click, bam, you built a model. You built an AI model yourself, and you're like, wow, it works, it's great. But also, and as things get more sophisticated, you won't have to do the coding. You won't have to necessarily understand all the complexities behind the scenes. You understand your business objective. So AI will become much more business focused or industrial focused on an objective. And that's when it becomes important to do return on investment analysis and things like that, so that you don't have science projects that you have, that you're using. You may have a lot of AI tools, but to get value out of them, now you need to target them toward tangible business cases that are quantifiable.
Yeah, and let's talk some of the tangible business cases, right? So AI is very popular, as you've referenced. Sustainability is also very popular, and perhaps it's going to become an enforced area, so it might be a compliance issue. Talk about how you're supporting that sustainability area for various companies.
Sure. You know, we're helping our customers today and in the future, you know, because different people are at different points on their journey to net zero. So take example of customers that are burning fuel and emitting carbon. We want to make them as efficient as possible. We want to find their underperforming assets that are burning excess fuel and emitting excess carbon, greenhouse gases as a result. But we also want to, you know, improve their overall efficiency. And then as they transition to renewable energy and maybe even alternate energies, we want to make that more efficient. And so what I mean by that is, you know, wind power can sometimes be expensive because you got to maintain it and you got to do with it. How can you make it more efficient? Well, AI can help make it more efficient, identify where all the problems are, so you can send a maintenance crew out. They can fix everything in one trip, super efficient, and then you drive the cost of renewable energy down so it's cheaper than traditional sources, and it becomes a no-brainer. Then you move to alternate fuels like hydrogen. You know, there's blue hydrogen where we're helping with carbon capture. We're using AI to do carbon capture modeling to make that as efficient as possible. But that's not ultimately where we want to be. We don't want to necessarily capture the carbon. We want them to go to true green hydrogen. Green hydrogen being renewable powered electrolysis. So you take water, you split out the hydrogen, and use renewable energy to do it. Today, super expensive. That's the problem with it. AI can help make it super efficient, drive the cost down, it becomes competitive, and it becomes the fuel of the future.
And on the same note, right, let's double click a little bit on is there a product or you have anything on a roadmap that, for instance, it measures the impact? You've just built this gadget. You want to be able to look in a software, is like, this was the carbon footprint that may be not just building it, but also the whole supply chain of getting the products in there. And
That's right. You've got to look at the whole value chain up and downstream to really quantify that. And I think hydrogen generation is a good example because you can't just look at the hydrogen production. Yeah, you can split hydrogen and or water into hydrogen and oxygen and so forth, but you can't. You also have to look at what's fueling it. And if you're using coal-powered or whatever it might be, then you're very non-green. And so you need to make sure that the whole thing, and then, like you said, supply chain up and down. When people, well, even looking at Aveva as an example, we use the cloud. We look at our cloud suppliers. Microsoft, they use green energy to provide power as much as possible to their data centers, to their cloud throughout the world. And so when we put our AI and our other software, other platform on Azure as our underlying infrastructure, it's powered largely by green energy, and we put it up there so multiple customers use the same code, super efficient. You don't have thousands of customers installing everything on-prem, running their own energy, supplying to the CPUs and computers and so forth. So it is a supply chain. You got to look upstream and downstream at the total carbon footprint.
Thank you, Jim, and appreciate the insights. And if you're in the audience and have questions for Jim or Jim's team, feel free to leverage the hashtags you see on the screen, Aveva World or IoT World, and we'll make sure that we get answers or bring somebody like Jim back to sort of provide an update.